These are the frequently asked questions videos for Algebra 2, Section 3.3, and they usually start with number 20 here. It says you want to decorate a party hall with a total of at least 40 red and yellow balloons with a minimum of 25 yellow balloons. Write and graph a system of inequalities to model the situation. And the first total that I saw up there was 40. And I saw at least 40, which means it could be exactly 40, or it could be more. And they want the balloons to be at least 40, so at least 40 would be 40, 41, 42, anything higher than that. And we're going to use red and yellow balloons. So this 40 is about total balloons, and I don't know anything other than the fact that they want both red and yellow balloons. So r plus y has to be greater than or equal to 40. But then it does say there has to be a minimum of 25 yellow balloons. So the yellows need to be greater than or equal to 25 is what they're really saying there. And so that system represents what's going on. And then what I need to do is figure out how I'm going to graph this. So I think I'll put my red balloons on my x-axis and my y balloons up my y-axis. And let's see, I need to go, what I'm doing right now is going through and finding the points, the zeros, for each of these functions. So that one needs to go out 40 in both directions, and this one, my y, being greater than or equal to 25, I need to make sure my y's go to at least 25. So maximum I'm really going to need here is 40, and I know I have 20 of these little things here, so maybe I will just go by twos. And I'm not going to write every number down because I don't want to clutter it up. Like so. And same thing up the other side. Again, you know, don't want to get too much clutter here. So now, my top line, I had 0, 40, and 40, 0. And it did have an equals bar, so I would want that to be solid. Ooh, that's got a bow to it, doesn't it? So, more like that. And the red and the yellow are supposed to be greater than or equal to 40. And again, you can test a point real quick. 0, 0. 0 is not going to be greater than or equal to 40, so I need to shade out this way. And then the second part of this was that the yellow need to be greater than or equal to 25. So here's my 22, 24, 25 would be right there. And if my yellows need to be greater than or equal to 25, that would mean that I need to shade above. So what I see right now is that I'm going to have this kind of truncated figure here that shows my double shading this way and up. Up from there. And it says, write and graph a system of inequalities to model the situation. So anything that's up in that region would meet those constraints that they gave us, which was, you know, staying 40 and above for the balloons and greater than 25 for the yellow. So again, you could pick out, you know, the fact that 30 reds and following that up, 34 yellows would be one solution, but pretty obviously, you know, this one's going to have infinitely many solutions because we really were not given a stopping point here for how many balloons we needed to have. So we would just represent that graphically. And then the next one that I thought you might need help was another word problem here, and this one was about the food pyramid. Says the food pyramid suggests that you eat 4 to 6 servings of fruits and vegetables a day for a healthy diet. It also says that the number of servings of vegetables should be greater than the number of servings of fruit. Find the number of servings of fruits and vegetables that could make a healthy diet. Use whole numbers only. And this is a problem that I used to hear from students, that they actually had to do this in their health class, come up with a poster, about the food pyramid. So I saw a total up there of 4 to 6. So the vegetables and the fruits that you eat, when they're added together, need to be greater than or equal to 4. But they also need to be less than or equal to 6. And if you're thinking, well, can't we make an and sandwich out of that one? You absolutely could. You could put your vegetables plus fruits between a 4 and a 6, or write them separately. That is totally up to you. Probably a little easier to graph with this 2-variable system, just leaving them separate as they are here. And then there was one other piece in here. It said that the number of servings of vegetables, the number of servings of vegetables should be greater than the number of fruits. So there it is. Vegetables should be greater than the numbers of fruits. And that's what we have here. And it says, find the number of servings of fruits and vegetables that can make a healthy diet. Use whole numbers only. Well, if you do it graphically, I'm perfectly fine with that. So we have some fruits and vegetables to look at here. So I think I will put my vegetables here and my fruits here. And again, I'm going through my head and saying, okay, so it could be 0, 4 or 4, 0. Finding the zeros for the first one, and this one could be 0, 6 and 6, 0, finding the zeros there. And if, for a second, we just pretend this is vegetables equals fruits, then that's that line y equals x that goes through that perfect diagonal, 1, 1, 2, 2, etc. So I have a little room to play around on this graph when we have 20 different spots for it. So I think what I will do is maybe go every 2. So my vegetables plus my fruits needing to be greater than or equal to 4 is going to put me at 0, 4, and 4, 0. And 0, 6, and 6, 0. And then if it has to be greater than or equal to 4, but less than or equal to 6, well, you can just look at some of the numbers. Again, realize 0, 0 is not going to do that. So 2 and 4 would do that. So we're looking at the region between those two. And again, that and sandwich kind of helps with that piece, that you know that it has to go in there. Then our vegetables and our fruits, remember we're going to use the line 1, 1, 2, 2, etc. to represent that. And then vegetables must be greater than fruits. So this is a good opportunity to take a peek at your chart and say, okay, well, where is that going to happen? For instance, if I pick 4 and 4 vegetables and 1.5 of the fruit servings here, well, my 4 is definitely going to be bigger than my 1.5 servings. So that would be shading under, like so. And this is the region right here that's going to make that happen. And they said they only wanted the whole number solutions. They don't want any half servings of fruit or anything like that. So this would be more of a discrete graph, a countable graph, and you would just go through and list any of the points in there that are in that, well, red zone on my graph. And let's see if we can get just a couple of them for you. 5 vegetables and 1 fruit would do that. Other ones that will meet both of those conditions We could do 4 vegetables and no fruits. I mean, there's a lot of them here, but I'm just going to list a few out. And then if we did 4, we'd have to go with 4, 1 to make that whole number. So again, you just go through anything in that red region for whole number solutions. And I probably should give this a name. It's a very nice graph, so maybe servings of fruits and vegetables. All right, never hurts. Like I said, some people had talked about how they had done one like this for their health classes in the past. Number 32, an entrance exam has 2 sections, a verbal section and a mathematics section. You can score a maximum of 1,600 points. So already I'm looking at my 1,600 points here, knowing that that's the max. Whatever the score is going to be, it's going to be less than or equal to 1,600, and that's going to come from the verbal plus the mathematics portion of the test. For admission, the school of your choice requires a math score of at least 600. So your math score needs to be greater than or equal to 600. And again, this says write a system of inequalities to model scores that meet the school's requirements, then solve the system by graphing. So we have those requirements listed up there right now. You have to make sure that your combined score is going to be less than or equal to 1,600, because that is the top score, and then your math piece must be greater than or equal to 600. So again, before I start thinking about what to use for intervals for my graph, I'm thinking ahead to finding those zeros. And then on the bottom one, that's just going to be, M, math score is 600. So I need to go up to 1,600 with these. And I am going to put the horizontal axis for the verbal part, and then math portion will be on my vertical axis. So let's see, 1,600, huh? So we could really, with the 20 spaces, go out to 2,000. So I will do 100, 200, 300, 400, 500 at a time. 6, 7, 8, 9, 10, 11, 12, 13. And that should help me figure out what I need. All right, so knowing that this is 20 by 20 helps out quite a bit. So now I need 0, 1,600, and 1,600, 0. Solid. And less than or equal to, pretty obviously, if you don't score anything, 0, 0 on this test for verbal or math, you're going to be in this region right here. But the math score is needing to be greater than or equal to 600. So here is the 600 cutoff. And math is going to be above that. So this triangle right here would be the region that you would need to score in order to get into that school of your choice. And again, we're just doing that graphically. You could certainly pick out, that you need to get 300 on the verbal and 1,000 on the math and pick some points, but better to solve this graphically so that you have that whole region to look at. Next group of problems I thought maybe, just maybe, somebody would get stuck on. Number 36 is asking us to identify the inequalities A, B, and C where this ordered pair is a solution. 36 says, how about 0, 0? Well, it's definitely a solution to A. It's in the shaded region. So for 36, one word for A. We check B. Nope, not shaded. We check C. Yep, it is shaded. So A and C would be the correct answer for number 36. Number 37 says, how about the point -2, -5? So -2, -5, that's definitely, as we're going down this way, going to be shaded on A. So definitely going to happen for A. And then for B, -2, 1, 2, 3, 4, 5, just kind of eyeballing it there. It looks like it's going to work, but again, you might want to use the slope just to make absolutely certain that things are going to happen the way that they should. So I noticed these two are grid points, which means this is going 2 to the left and 3 down. So from this point, 2 to the left and 3 down, it looks pretty accurate, and graphically it appears that that's going to work. So that would also be B. Last graph over here, -2, -5, not going to happen. So just A and B in that. I might as well take that little comma off there then. Okay, then maybe somebody would ask about 46. I don't know. I think after you realize that the last two down there, the bottom two, are just telling you that you have to stay in the first quadrant. I think you'll be okay after that. Is it saying your x values have to be greater than or equal to 0 and your y values have to be greater than or equal to 0? And the only place that's going to happen is in first quadrant. So I don't even need to really worry about graphing those two. But obviously stay in first quadrant, and that way you'll know where you need to go. And then if you just quickly do the zeros for the top graph there, you're going to see you're at 0, 8, and 8, 0. And, well, let's see, I'll just get a couple of numbers on here. And just going by twos. So now I have those, 0, 8, and 8, 0. And that said x plus y has to be less than 8, so I'm going to take off some of this to make that dashed, fill it in a little bit. But less than, 0, 0 obviously is going to work there. 0 plus 0 is less than 8. And again, I'm just staying in first quadrant here. So anything in that triangular region will be a solution to this, including anything on the x or y axis here, because it did have equals bars for these last two. And remember, where we don't include solutions would be on our nice dashed line right there. That dashed line signifies that the things that are on that line are just part of the boundary. They are not a solution to that system. And those were the ones that I thought you might need a little extra help with. Hopefully the rest of this will go well.